I believed you actually watched our videos whereby we talk about the principle of conservation of mechanical energy. If you haven't watched that video, we recommend you to watch that first so that you can understand what we're talking about in today's video. Welcome to Edu-ca-te. So today we're going to be talking about the mechanical energy of an object moving up an incline. So here we're not actually focusing on the whole point of mechanical energy, but we are focusing on calculating the height at position number B. Okay, so here let's see what do we have. We are given the mass of 2 kg, the velocity at A, meaning that we are given the velocity here, meaning that the ball at A, it is moving at 3 meters per second, and then at B is 0 meters per second. Well, sometimes they won't tell you that at B it is 0 meters per second. They might tell you that the ball is at rest at B, meaning that at point B, the velocity is close to 0 meters per second. So they can express this as at rest. All right, so we have got everything we need now. Now let us go to calculation. What do they want us to calculate actually here? They want us to calculate here the height of B, exactly how high does this ball reach, all from A to B. So that is your height. So now we know that this ball moves from A to B at velocity 3 meters per second, so it is moving up the slope. So now we go to calculating the height at B. So first of all, let us look at A. At A, the ball is at the surface, meaning that the height is equals to 0 meters. So when a ball or any object is at a surface, the height is equals to 0. Now let's go to our formula. Our formula states that the mechanical energy at the initial point is equals to the mechanical energy at the final point. Therefore, mechanical energy is conserved. So now let us actually look if we have the following. Do we have kinetic energy at A? No. Do we have potential energy at A? No. Do we have kinetic energy at B? No. Do we have potential energy at B? No. Therefore, what do we have? We have got the mass, we have got the velocity, we have got the height at A, we have got the velocity at B. So it means that we have to expand this formula. So here we are given EK. EK is the kinetic energy, and its formula is half mv squared. Therefore, we can represent EK with half mv squared. Plus, the potential energy is given by mgh. Mgh is actually having mass, gravitational acceleration, and height. This is all at point A. Is equals to half mv squared as well, plus mgh at point B. So we're actually going to use the necessary measurements. I mean, the velocity at A and B is different, so do not mistake in terms of substituting the correct values. So here, let us go to half. To the kinetic energy formula, which states that half of mass, we are given the mass of 2 kg, so the ball weighs 2 kg. And then the velocity, here they tell us that it is moving at 3 meters per second. We substitute. The mass is 2, gravitational acceleration is constant, the height of this ball, let us look at point A. At A, the ball is at the surface, meaning that it is not higher than the surface, therefore the height is 0 at A. Therefore, we now go to point B. At point B, you can see it's high up there, all the way there. So at point B, there must be a certain height above 0 because the ball is actually above the surface. You can just see it. So here, let's go to the kinetic energy formula, where we can substitute our mass for 2 kg and then your velocity for 0 squared. Your velocity is 0 squared because we are told that the ball is actually resting at B, or the ball does not move further at B. So here we add it to the mass of B of the ball is 2 multiplied by 9,8, which is the gravitational acceleration. Remember that the gravitational acceleration here on Earth is always constant, meaning that the Earth pulls the same gravity over different objects of different masses. Therefore, here we have multiplied by height. So our height, we want to actually find that out. What is the value of our height actually? We don't know it. Therefore, we'll write h. Well, at least we have to solve for something. That's why we have to have at least one thing missing in this whole equation. Well, here you can see that this is indeed 0. Okay, let's look at half of 2 times 9. So this is half of 18, that is equal to 9. and then is equal to half of 2 times 0. Once you multiply everything with 0, 0, therefore we've got 0 over there. And then plus 2 multiplied by 9,8. Well, 2 multiplied by 9,8 gives you 19,6. Remember, we still have the height multiplied to 2 times 9,8, which is 19,6. Well, you can get rid of these zeros and remain with 9 is equals to 19,6h. And then I recommend you to actually write it this way, as 19,6h is equals to 9, so that your h will actually be equated to the answer, not the answer equated to the h. So here, what do we do? Can we say h is equals to 9? No. Why? It is because there is this 19,6. We have to get rid of it. So we divide everything by 19,6 over here as well as here. So when we divide 9 by 19,6, we'll remain with a height of 0,46 meters. So this tells us that the height at position number B is equals to 0,46 meters. So this is how you can utilize the principle or the law of conservation of of mechanical energy to be able to solve different things on an object's motion. Thank you for watching. Don't forget to subscribe, tell your friends to stay tuned.